Hi, my name is Mr. Peck from Ideas Inc. School, and today we will be talking about elements, compounds, and mixtures. Let's start with elements. An element is a substance that cannot be broken down further into two or more simpler substances by chemical means. All elements are arranged in a periodic table, and they are arranged consecutively according to their atomic number. This atomic number represents the total amount of protons found in the nucleus of the atom. Elements are also organized in vertical columns known as groups and horizontal rows known as periods. So why are elements arranged in the same group? These elements in the same group have similar chemical properties. For instance, sodium in group 1 can react violently with cold water to produce hydrogen gas. Thus, potassium, which is also in the same group, will also be able to react vigorously with cold water to produce hydrogen gas as well. Then why are elements arranged in the same period? Elements found in the same period have the same number of electron shells. For instance, sodium and magnesium are found in period 3 because they both have 3 electron shells. We are going to be referencing the periodic table for the next part of this chapter. Please pause the audio clip and study the annotated periodic table in the notes. Let's begin. Every box in the periodic table contains a unique element. Take magnesium for example. From top to bottom, the number 12 represents the atomic number, and as mentioned previously, this number represents the total number of protons in the atom. Mg is the chemical symbol of magnesium. We use this when writing chemical equations. Please note that the starting letter of all chemical symbol must be written in capital letters. Next, the full name of the element is spelled under the chemical symbol. And finally, the number 24 represents the atomic mass of the element. This is the relative mass of the atom as compared to 1/12 of a carbon atom. Next, there are certain names used to describe groups of elements. Group 1 elements are known as alkali metals. Group 7 elements are known as halogens. Group 0 elements are known as noble gases. And the huge chunk of groupless elements found in the middle of the periodic table are known as transition metals. In the annotated periodic table, I have included a bold staircase line starting from boron down towards astatine. This zigzag line separates the metals on the left and the non-metals on the right side of the periodic table. Therefore, as we move from left to right on the same period, these elements lose metallic properties. In addition, elements close to the zigzag line have both metallic and non-metallic properties. These elements are known as metalloids. For instance, silicon has the shiny luster of a metal but is brittle like a non-metal. Silicon can also conduct electricity, although it is technically classified as a non-metal. On this note, let's now discuss about the differences between metals and non-metals. Most of the differences, like their appearance, melting and boiling points, conductivity of electricity, and heat have been taught before. Thus, we will only be focusing on 3 new differences. Metals are malleable, ductile, and sonorous, while non-metals are not. Metals are malleable because they can be hammered into shapes without breaking. Metals are ductile because they can be pulled into wires. And lastly, metals are sonorous because they produce a ringing sound when struck. Next, we will talk about how the reactivity of elements change in a group. Reactive metals are found in group 1, while reactive non-metals are found in group 7. However, totally unreactive elements are found in group 0. With regards to metals, reactivity increases down the group. For instance, in group 1, lithium found at the top is the least reactive metal, while cesium and francium at the bottom of the group are the most reactive metals. On the other hand, the reactivity of non-metals decreases down the group. For instance, in group 7, fluorine found at the top is the most reactive halogen, while astatine at the bottom is the least reactive halogen from that group. Elements from group 0 are called noble gases because they are very unreactive. These elements are inert and very stable, thus they do not take part in any chemical reaction. In the next section, we will be discussing about atoms and molecules. Atoms are the smallest particles found in an element, while molecules are made of 2 or more atoms chemically combined together. Monoatomic atoms only consist of single atoms. For instance, noble gases like helium and argon are only made of single atoms as they are very stable. Diatomic molecules are made of 2 atoms that are chemically combined. For instance, nitrogen, oxygen, and group 7 elements are made of 2 chemically combined atoms. I have enclosed these diatomic elements in an L shape in the periodic table found in the notes. Now let's discuss about the different types of molecules. There are 2 types of molecules. The first type are molecules of elements. These molecules are only made of the same type of atoms. For instance, nitrogen and oxygen molecules are only made of nitrogen and oxygen atoms respectively. While the second type are molecules of compounds. These molecules are made of different types of atoms. For instance, the molecule methane is made of carbon and hydrogen atoms, and the molecule ammonia is made of nitrogen and hydrogen atoms. Now we will move on to the most important part of the chapter. Here we will be discussing about compounds and mixtures. A compound is a pure substance that contains two or more different elements chemically combined in a fixed ratio. Some examples include water, carbon dioxide, ammonia, methane, sodium chloride, which is commonly known as salt, and calcium carbonate, which is commonly known as limestone, marble, or chalk. We can also deduce the different elements found in a compound by looking at their names. Note that any name ending with the letters I, T, E, or A, T, E means that oxygen is present in the compound. And if the name ends with I, D, E, then no extra oxygen is present. For instance, sodium carbonate contains sodium, carbon, and oxygen. Note that the name carbonate ends with the letters A, T, E. Thus, oxygen is present in the compound. Calcium nitride contains calcium, nitrogen, and oxygen. Note that the name nitride ends with the letters I, T, E. Thus, oxygen is also present in the compound. Ammonium sulfide contains nitrogen, hydrogen, and sulfur only. Note that the name sulfide ends with the letters I, D, E. Thus, no additional oxygen is present. Now let's move on to mixtures. A mixture consists of two or more substances added together physically without any chemical bonds being formed. Some examples include air, seawater, alloys like brass, bronze, and stainless steel. Substances like petrol, beer, milk, and blood are also mixtures. To find out more about what these mixtures are made of, you can pause the audio and refer to the notes. There, I have broken down the mixtures into their components. Now let's discuss about their differences. Firstly, a compound is made of two or more different elements chemically combined in a fixed ratio, while a mixture contains two or more different substances that are physically combined in no fixed ratio. Secondly, a compound can only be separated back to its starting elements by chemical means, while a mixture can be separated back to its starting components by physical means. Chemical means of separation includes processes like thermal decomposition and electrolysis. For more information about the electrolysis of water, please pause the audio and refer to the diagram in the notes. If we look closely at the setup, note that the volume of hydrogen gas collected is twice of the volume of oxygen gas collected. Physical means of separation includes processes like filtration, distillation, magnetic separation, and crystallization. All these techniques will be discussed in subsequent chapters. Next, we will move on to their third difference. A compound is a pure substance, thus it has a fixed melting and boiling point. On the other hand, a mixture is an impure substance, thus its melting and boiling point occur over a range. The next difference between compounds and mixture is that a compound's physical and chemical properties are very different from its base elements, while the physical and chemical properties of a mixture are an average and are the result of its components. Let's demonstrate this using an example. When gray iron fillings is added to yellow sulfur powder, they form a mixture. This mixture has all the chemical and physical properties of its starting elements. For example, the resultant color is a mixture of the two substances and the mixture retains the magnetic properties from iron. However, when the mixture is heated, the elements undergo a chemical reaction to produce a new compound known as iron sulfide. This new compound loses all its previous physical and chemical properties. As a result, iron sulfide no longer has any magnetic properties and it now has a new black appearance. Lastly, a compound is formed due to a chemical reaction. Therefore, a lot of energy is given off or taken in during the process. However, when a mixture is formed, little or no energy is given off or taken in when the substances combine. We have come to the end of the chapter. If you have any doubts, please approach Mr. Peck. Thank you for listening and have a nice day.